Hello, today we'll discuss about chi-square distribution and its application using SPSS. So this objective of this lecture is to have some ideas about the advantages and disadvantages of the non-parametric statistical test. Learn how a non-parametric statistical test is conducted when the variables are measured on nominal scale and the measurement are of independent nature. And finally, to learn how to apply chi-square test to check the association between two categorical variables. Now, before going to the actual applications using SPSS, first of all have some ideas about the chi-square distribution. Now a random variable is said to follow chi-square distribution if its probability density function is given by this. So chi-square distribution is a continuous probability distribution where the range of the values of the range of the variables is 0 to infinity. So only positive values of the variable will be considered for chi-square distribution. Now the two constant k and n, this n appearing in this chi-square distribution, k is a constant value, n is a positive integer, and then n is also called the parameter of the distribution and it is also called the degrees of freedom. So depending on the value of the n, the shape of the distribution will also change. Now come to the some important properties of chi-square distribution. The chi-square distribution has mean equals to its degrees of freedom, that is n, while its standard deviation is given by square root of twice degrees of freedom. The chi-square distribution is positively skewed starting from 0 and goes up to infinity on the right. Now another important property of chi-square distribution is that suppose you are considering two independent variables x and y which are following chi-square distribution with degrees of freedom n1 and n2 respectively. Then if we take the summation of these two variables x and y, here we have written though x1 and x2, it will be x plus y. Then their sum will also follow a chi-square distribution with degrees of freedom n1 plus n2. Now this can also be applicable when we are taking the difference of the two variables x1 and x2. That means x1 minus x2 will also follow chi-square distribution, obviously with degrees of freedom n1 minus n2. Now two important theorems about chi-square distribution. Suppose there are n independent normal variate, that is z1, z2 and zn. If we take the square of these individual standard normal variable and take the summation, that is like this, zi square, and her summation is taking from 1 to n, this variable will follow chi-square distribution with degrees of freedom n. And second theorem is that suppose we are taking a random sample x1, x2, xn of size n from n normal population with the mean equals to mu and standard deviation sigma. Then if we calculate this variable, that means individual sample value minus population mean square divided by variance of the population and take the summation over all the random sample values, then this will follow chi-square distribution with degrees of freedom n minus 1. Now the test statistic used in chi-square distribution. We know that any statistical test we must use a test statistic, be it a t distribution or f or z or any other distribution. So chi-square test statistic is given by this chi-square test statistic is given by the observed frequencies in a particular category minus expected frequency in that particular category, take the square divided by expected frequency and take the summation. Now the shape of the chi-square distribution. As told earlier that the shape of the chi-square distribution will depend on the degrees of freedom. So when the degrees of freedom is 2, the shape will like this. Now as the degrees of freedom increases gradually, the shape of the chi-square distribution becoming like this. Say for degrees of freedom 4, this is the shape of the chi-square distribution, this one. And see, as the degrees of freedom becomes larger, it becomes almost like a bell shaped as it appears for normal distribution. Now the decision rule. So like any other statistical test, the decision rule remains the same. We have to choose the particular level of significance, and at that level of significance we have to compare the calculated value of the chi-square with the critical or table value of the chi-square. If the calculated value of the chi-square is greater than the critical value of the chi-square, then null hypothesis will be rejected in favor of the alternative hypothesis. Alternatively, we can also compare the probability value of the calculated chi-square. Now if the probability value of the chi-square is less than the level of significance, that means 0.05 at 5% level of significance, we can reject H0 and accept H1. Now what are the areas where we can apply chi-square test? Chi-square test is applied in the following cases. It's a test of independence. Suppose there are two variables which are categorical. Now we want to check the association between the two variables. Then we can apply chi-square test. We will show this one just after few moments. Then chi-square test of goodness of fit. Now suppose there is a sample data and we want to fit the normal distribution to this particular data set. Now chi-square distribution will enable us to examine to what extent that particular data fits normal distribution well. Thirdly, chi-square test can be applied for its correction for continuity of the data or for testing the population variance, and finally it can also be applied for testing the homogeneity of the statistical data. Now one important thing we have to keep in mind while applying the chi-square test. That means when we are preparing or calculating the observed frequencies and expected frequencies for different categories of the variable, if we come across this observed and expected frequencies with smaller number less than 5, say particularly here 3 and 1 are less than 5, we have to club them to the neighboring observed and expected frequencies to make the expected frequencies at least greater than 5. So here 9 and 3 will be clubbed together to produce 12, and 6 and 1 will be clubbed together to make 7, which is greater than 5. Now particular application of chi-square test, that is chi-square test of independence. Now suppose we have this following types of problems. Now we want to check whether voters can be classified by gender is independent of the political affiliations. That means we want to check the association between gender of the voters and their political affiliations. Similarly, we can check the gender of the students and the course of study they are choosing. Or for wage earners who are classified by their education level are independent of the income. That means we want to check whether there is some association between education level of the wage earners and their income level. And similarly we can perform in other cases like this. So see here all the variables are categorical and we want to check the relationship or association between these two categorical variables. Now the contingency table. Now when we have come across this kind of categorical variable, the variables can be presented in a table format like this. Say variable A has these categories A1, A2 and AC, and variable B has the categories B1, B2 up to BR. See, variable A has arranged in these columns A1 to AC, and variable B has arranged in B1 to BR rows. So O11 is the observed frequencies or the number of cases falling in the category B1 and A1. Similarly, O12 is the number of cases or observed frequencies for the category B1 and A2, and so on and on. ORC is the number of observed cases falling in the category BR corresponding to variable B, and AC corresponding to the variable A. Now here we have taken the row total R1, R2 and RR for the corresponding rows, and C1, C2, CC for the total of the corresponding columns. N is the grand total of, that means total number of cases or sample size. Now when we have this contingency table with the observed frequencies, each of the cell of the each cell of this contingency table will have also expected frequencies, which can be calculated using compound probability theorem using the formula. This expected frequency of a particular cell ij is given by this ith row total divided by sample size multiplied by jth column total multiplied by samples divided by sample size multiplied by the grand total. Or simplifying, we can say that expected frequency in the cell ij is ith row multiplied by jc rth row total of ith row total multiplied by jth column total divided by total sample size. So in this way we can calculate the expected frequencies for different cells of the contingency table. Now once we are in a position to get the observed and expected frequencies for the different cells of the contingency table, we can apply the chi-square test in these steps, in the form of these steps. First step is the stating the hypothesis. Now in chi-square test, always we have to take the null hypothesis as the no difference between observed and expected sets of frequency. Against the alternative, there exists a difference between observed and expected sets of frequency. Then in the second step, we have to collect the random sample and record the observed frequencies for each category and arrange them in a contingency table. Calculate the expected frequencies for each category by using that compound probability theorem, and finally calculate the chi-square test statistic using this formula. Now choose a particular level of significance. Now it is normal custom to have 5% level of significance, so I have taken alpha equals to 0.05. Now that in step 4 the chi-square value, this one will have degrees of freedom n-1, provided the expected frequencies for a particular cell are 5 or more for all the categories. And finally at step 5 we will find the critical value of the chi-square at this particular level of significance alpha equals to 0.05, and then final step, compare this critical value with the calculated value of chi-square. Now if the calculated value is less than critical value, accept H0, otherwise accept H1. Now take a particular real life example. Now suppose we have asked 200 adult persons about their opinion on TV shows. Now the TV shows are primarily categorized as entertaining, educational and waste of time. Now respondent could answer only one option at a time. That means they can say that TV shows is either entertaining or educational or waste of time. No two answer can be given at the same time. So we have two categories or categorical variables: gender of the respondent and opinion about the TV shows. Now the data, on the basis of this data we can confirm or we can examine whether there is a relationship between gender of the respondent with their opinion about TV shows. So we frame the hypothesis as H0, no association between gender and opinion, against there is some association between gender and opinion. Now look at the actual data. We have the data in SPSS format. So SPSS is opening. Yes, it is the data. See, we have two variables, gender and opinion. See, there are 200 observations. Yes, there are 200 observations. See here. See, 200 observations are there. Now this is the data view of the SPSS window. Now come to the variable view. See, gender and opinion both are numerical variable. Now values, click here, you will get the two values for gender, male and female. Male is coded as 1 and female is coded as 2. Now for opinion, similarly we have three categories: educational, entertaining and waste of time. Now entertaining is coded as 1, educational is coded as 2 and waste of time, simply I have written here waste as 3. Now we have the data and we have to perform the chi-square test as well as to get the contingency table. Now go to analyze button, descriptive statistics, cross tabs. This small window will come. Now we have to put the variables into appropriate rows and columns. I have taken gender into rows and opinion into column. Now go to statistics option. See, there is option chi-square. We have to check this button and click continue. Now go to cells. See, the count we have to estimate, that is observed frequency and expected frequency for different cells of the contingency table. Check these two boxes and click on continue. Now it is ready. Click OK. Yes, this is the output. See, we have 200 observations, so valid case is 200 and there is no missing cases. It is good to have no missing cases or missing values. This is the contingency table. See, we have two variables, opinion and this is gender and opinion. Gender has two categories, male and female. Opinion has three categories, entertaining, educational and waste of time. Now this count and expected count. Count means simply observed frequency and expected count means expected frequency. Say here we have 200 total observations. Out of 200, male is 90 and female is 110. Out of again 90 male, 28 is telling that TV shows are entertaining, 12 of educational and 50 is telling that it is waste of time. Similarly, 52 female out of 110 is telling that it is education entertaining, and so on and on. And similarly, we can calculate the expected free count for these different cells. These are written here. See, expected count 36, 18 and 36 and so on. And the chi-square test. See here, the Pearson chi-square value is 16.768 and it is the calculated value of chi-square with the degrees of freedom 2. And here the probability value of this chi-square test statistic is 0.00, which is less than the level of significance. That means we will reject the null hypothesis and accept H1 as this probability value is less than 0.05. So if we reject H0 and accept H1, what does it mean? It means in terms of our, come to this hypothesis, that is H0, no association exists between gender and opinion. So we are rejecting this hypothesis and accepting the alternative. That means there exists some association between gender and opinion. Okay, that's all about chi-square test of independence and its applications using SPSS. Thank you very much for being with me for a while.